Well, one thing that I'm seeing is this. Now, what if you have a statement that says, you want to write this as an equation, something like 3 less than a number x is 17. Okay. What is, now if I think about this in terms of operations, if I'm saying less than, does that sound like that's meaning subtraction from, right? Okay, so how, would somebody like to volunteer, how would we write this sentence as a math sentence, aka an equation? Yes, ma'am. 3x. Okay, we'll try that.
Oh wait, no.
Okay.
3 minus x.
Okay. That's what 9 out of 10 people were trying first on this one. I can see all your attempts, and that's what people were trying first. Okay. There was an issue with that though. That was giving you the red X. Now, was that a Moodle issue? No, that's not quite right. It's very close, very close. Sometimes what's useful to do though, and I want to key in, I'll give you guys are chomping at the bit here, I'll give you a chance in a second. Sometimes what you want to do when you're doing problems like this, where you're trying to come up with sort of a general way to express something, is test it. Pick some specific numbers and just see if it works. So, what about in this case right here? Let's what if x could be any number? What if it were 10? And then that would be the answer, wouldn't it? But 3 less than 10 would be what?
7.
Would be 7. Okay, so if x is, you say it again, if 3 less than 10 is 7, right? So if x is 10, does 3 minus 10 equal 7? No, it doesn't. If I say 3 less than a number, 3 less than 10, to get the answer, what did I do? I didn't say 3 minus 10. Okay. I would do 10 minus 3, wouldn't I? So if 3 less than 10 is 10 minus 3, then you see the trend. 3 less than x would be x minus 3, right? See how that works? Sometimes it helps to just pick a specific one and just see, does that work? If it doesn't work, then back to the drawing board, okay? So it should be x minus 3, okay? Yes, sir?
I have a problem with one of the ones. No, it's 5 less than the quotient of the number x and 3.
Okay, so, okay, good. 5, now let me say it again. 5 less than the quotient of x and 3 is what now?
13.
It's 13. Okay, let me write it down. That's a lot of writing. But. Quotient of x and 3?
Yeah.
Is
13.
13. Okay, well, what do we know here? What does the word is always correspond to?
Equals.
Equals. Okay, so we know we're getting equals 13. Now, what about this stuff right here? What's a quotient of x and 3? Okay, quotient. I'm seeing a couple things, but I'm seeing some people doing this. Yeah, it's a quotient just means I'm dividing those two things. Okay, so the quotient of x and 3 means x divided by 3. Okay, that's like a ratio, another word for ratio. So if I want to do 5 less, then this is just going to end up being x over 3, right? Okay. What's 5 less than x over 3? Good. X over 3 minus 5, isn't it? Okay, good. Okay. So that's the kind of stuff, I think on that last assignment, that's where people are having probably the most trouble. And there'll be other questions, but we'll hit those when we get down there maybe. Okay, what I want to really quickly just review with you today, very, very short stuff. I want to look at inequalities, at solving inequalities in one variable. Okay, so what do we do if, well, first of all, what if I've got something like this? What if I've got 3x plus 1 is less than 16? whenever I'm solving for a variable, we're trying to isolate the variable, right? Now, the steps you go through, the algebra that you do when you're using an inequality, and the inequality could take many forms. It could be a less than, it could also be a less than or equal to, okay? It could be a greater than or a greater than or equal to. In this case, it just happens to be a less than, but any of those, or the other one that could work, that's also not equal to. That's another form of inequality. But mainly, we just use this one and those three, right? The algebra that you use when you're solving inequalities involving any of those signs is the very same stuff you do for equations with one slight difference that we'll get to. Now, how would we go about isolating x here? What are the two steps in order I would do to get the x by itself? Yes, ma'am?
-1.
Subtract 1 first. That gets rid of that, and then divide by 3. Good. Okay, so if we do that stuff, if we subtract 1, we get 3x is less than 15. Divide by 3, and I get, good, x is less than 5. Now, if I wanted to graph that on a number line, let's say that's 0, 1, 2, 3, 4. Whoops, I picked that number, didn't I? Let's make this like 2, 3, 4, 5, 6, 7. What's that graph going to look like? The graph of that solution. Okay, open dot. Good. Open dot where? This is the x-axis. At 5. Good. And which way am I going to shape? If x is less than 5, yeah, going to the left, aren't I? Less than and left. So it's going to look like that. Now, why is it an open dot? Okay, because it's not including the 5, is it? We're only taking all the possible values of x that are less than 5, but not 5. 5 is just the boundary, but it doesn't count. It's not part of the solution. Now, how could I fill in that dot? What would I have to do to my inequality to fill in the dot?
Switch it.
Yeah, I got to put an equal sign, right? And here's I mean, you guys probably all know this, but if you want a little mnemonic device to remember that, it takes more ink to write less than or equal to than less than, and it takes more ink to fill in the dot, right? Okay? Okay, last issue then. So, yeah. Oh, hang on. Yes, ma'am.
If you times or divide by negative.
Okay, yeah, very good. What happens, yeah. So let's look at an example where there's negative in it. So what if we've got one like this? What if we've got -3 plus 1 is greater than, did I do greater than last time? I did less than, okay. Greater than or equal to -3x. Okay. So what about this one? What are the two steps in order I go through to isolate the x this time? First subtract 1, good, and then divide by negative. Okay, so let's go through these step by step. Okay, so first I subtract 1, that's going to give me a -3x on the left. What's it give me on the right? Okay, now I'm going to divide both sides by -3, and that gives me an x here and a -5, but what do I have to remember? Got to flip the inequality sign. There's the one difference. Okay, hey, I need your attention, please. Thank you. The one difference between the algebra you're going to do on this assignment with inequalities and the algebra you did on the previous assignments is just that one thing. If you multiply or divide both sides of an inequality by a negative number, you got to flip the inequality sign. Otherwise, it's the same. Okay, make sense? Okay, so this is going to be a short assignment, just to kind of get you warmed up. Tomorrow, just so you got kind of a heads up here, tomorrow, here's what we're going to look at. So I'd have to flip this around, wouldn't I? Let me finish this. So that's a less than or equal to. Here's what we're going to look at tomorrow. We're going to look at solving stuff like this, just to get you thinking about it. Something like that. Compound inequalities. Okay, it's really not much harder, but that's what we'll look at. Okay, off we go. 209. I think. Hang on, one sec. Actually, let me check.